Welcome to the third episode of the series Algasm. In this video, we're gonna be going over the longest path in a tree. Let's get started. So, in order to find the longest path in a tree, the first thing that comes to our mind, the brute force search. The solution 1 could be finding the distance between every pair of the vertices and return the maximum of these values. To find the distance between pair of vertices, we can use DFS or BFS. Here we are using BFS, and the BFS function is slightly augmented to return the distance between the given two vertices. So the code looks like this. We're calling BFS over every pair of vertices, and we're just finding a maximum of these values, and the modified BFS looks like this. We are using an array of type pair of bool and int to mark the vertices as visited and store a distance from the given vertex, and we are initializing it with the initial values here, and we need a queue, of course, and just we are doing the BFS here. We are pushing into the queue, marking it as visited, and iterating over its adjacent vertices. And this process continues till we find the end vertex, and we'll just return the distance between the two vertices. That's it. So coming to time complexity, we are running BFS on every pair of vertices. So there are V vertices, so we are calling BFS for V squared times, and the BFS itself takes order of V plus E time. But we are dealing with trees, so we know that the number of edges are 1 less than the number of vertices. So let's take V and E as 1, and BFS time complexity then becomes 2V. So the total time complexity is 2V squared into V, which is nothing but order of V cube. And the space complexity, we are taking a visited array of size V and a queue which can be at most go up to of size V. So we can say that the space complexity is 2V. So it is order of V. So now let's try to optimize this further. So instead of calling BFS on every pair of vertices, if we modify BFS such that it finds the farthest node of vertex from a given node and calculates its distance, then the maximum of all these values is the answer. So the code looks like this. We are calling BFS on every vertex to find the farthest node from this vertex, and we are passing the reference of the answer variable, and we are updating the answer, and the modified BFS looks like this. It almost looks exactly like the previous BFS method, but while traversing through the adjacent vertices, we are updating the answer. The time complexity would be, we're calling BFS for V times, so the time complexity would be V into 2V time, which is nothing but V square. So the time complexity is order of V square. And the space complexity, we're taking a visited array of size V, and the queue could go up to a size V at max. So the space complexity would be V plus V, that is 2V. So the space is order of V. We can still optimize this approach. Let me put it this way. If I take a vertex and traverse the tree, we will end up at one of the farthest vertex in a tree. How do I prove it? Let's say you have chosen a random vertex and do a traversal. You will surely end up in one of the farthest pair of vertices. From that vertex, if we do a traversal again, we'll find out the other end of this longest path. Let's take an example. On this tree, no matter which vertex I choose and I do a traversal using a BFS or a DFS, I'll surely end up at one of the vertex in the longest path. So from here, if we do a traversal again, BFS, we'll end up at the other end of this longest path. To understand this, let's rearrange the tree like this. Let us put the starting vertex in the center, and arrange the adjacent vertices around it in a spiral order. In each iteration of BFS, we will visit all the immediate neighbors. In the next cycle, their neighbors. And in the next cycle, their neighbors. So in this way, we'll surely end up at the farthest node, which is one of the pair of vertices of the longest path in a tree. If anyone could come up with a mathematical approach to prove it, please share with us, guys. And the code looks like we can choose a vertex randomly, or we can just start with the starting vertex, that is a 0 or 1, depending on the way you start counting your vertices. So we have chosen entry point and we ran a BFS on it, and we found one of the pair of vertices that belongs to the longest path. From this vertex we are again doing a BFS. Now we'll end up at another end of the pair of vertices of the longest path. This approach just returns the starting and ending point of the longest path. You can just write some code yourself to find out the distance between these nodes. The BFS method looks like this here. It's almost same as the previous two BFS methods, but here we're just using an extra variable to store the last visitor node in the BFS traversal, and we are just returning it. Thanks for watching. See you in my next video.